This is using algebra to solve a geometry problem. And it is page 15, problem number 50. And what I'm given is I'm given 3 points. Point A is -2, 5. So I have -2, 5. That's point A. Point B is 12, 3. That's point B, 12, 3. And then point C is 10, -11. 10, -11. That's point C. So I have 10, -11. What I'm supposed to do is first make this into a triangle, which I can do. Here's one line, one leg, another leg, and a third leg. And I am supposed to verify that the triangle is a right triangle, and I'm supposed to find its area. So first let's figure out how to verify that it's a right triangle. Well, the way I can verify that something is a right triangle is if it fits the formula a squared plus b squared equals c squared. That's our Pythagorean theorem. And if our sides, a, b, and c, fit this formula there, then I'm going to know that it is in fact a right triangle. So I'm going to start by labeling our sides. I'm going to label our sides opposite the angle, which the side that's opposite the angle. So my side A is opposite angle A, and I'll put that in lowercase a. And my side B, I'm going to put over here opposite the angle B, and my side C, I'm going to put opposite the angle C. Now, I need to point out here, they gave me this point A, B, and C. It might not be the same as the A, B, and C in the Pythagorean theorem. The main thing I need to know with the Pythagorean theorem is that this is the hypotenuse, and these two are the legs. So once I figure out the sizes of these different sides of the triangle, then I'll be able to figure out which one's the hypotenuse, and then see if it is in fact a right triangle. So for reference, since I need to figure out the length of each side, I'm going to write down the distance formula. So d p1 p2, so the distance between any 2 points, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. How can I apply that in this case? Well, let's start with A, since we may as well just be alphabetical about the whole thing. So my side A is going to go from this point here to that point there, from B to C. So the length of side A, d, I'll put of A, is equal to the square root. Now I'll use B as my x2. So I'm going to have 12 minus 10 squared plus 3 minus -11 squared. Once I figure that out, that's going to be my distance of A. It's going to be the length of side A. So that's equal to square root, I'm going to put a little longer here, of 2 squared plus, well, it's 3 minus -11, so that's 14 squared. Since I'm not so good, I know my squares up until 12, but I don't know what 14 squared is. I'm going to pull up my calculator. I'm going to go 14 squared, 196. So that is equal to the square root of 4 plus 196. That's equal to the square root of 200. Now I'm looking at that, I know 200 has a perfect square in there someplace. It has a perfect square of 100. So that's equal to the square root of 2 times 100. So I can take my square of 100 out, and that is equal to 10 radical 2. So side A, go back up here, is equal to, let's make it green, huh? Side A is equal to, the distance of that is 10 radical 2. That is the distance between B and C, which is our side A. Let's move on here and do side B. So my 2 points for B is a negative 2, 5, and 10, negative 11. So I think I can memorize those long enough to get down here. So I'll use a different color. My distance formula, so I'll go D of side B is equal to, just write the formula again, since I can't see it, is equal to x2 minus x1 squared plus y2 minus y1 squared. So I'll plug in my points here. That's equal to the square root of negative 2 minus 10 squared plus 5 minus negative 11 squared. So this is equal to the square root of negative 12 squared plus, 5 minus 11, that would be 16 squared. And I know that this is 144, but I don't know what 16 squared is, so I'll do it on the calculator. I'll go 1/6 squared. That's 256. Wow, that's a big number. Plus 256. That, that's interesting. That's equal to the square root of 400, which is a perfect square. That's equal to 20. Interesting. So now I know that side B, let's go all the way back up here to the top. Side B is 20. Now let's calculate side C. Side C stretches from the point negative 2, 5 over to the point 12, 3. So let's go down to the bottom here again and do ourselves another distance formula. I'll write it again so that we can see it. Distance of C is equal to the square root of negative 2 minus 12 squared, those are my x values, plus 5 minus 3 squared. So I have, that's equal to the square root of, well, this would be 14 squared plus 2 squared. I think I had 14 squared earlier, didn't I? I did 4. Ooh, I had 14 squared plus 2 squared. So it's 196 plus 4. Square root of 196 plus 4. That's equal to the square root of 200, which is still equal to 10 radical 2. So that's our side. The final side is 10 radical 2, side C. 10 radical 2. Well, one thing I know about right triangles is that the hypotenuse, by definition, is always the longest side. So if I have two sides that are equal, that side there, C, and that side there, A, if they're equal, the two sides are equal, then the other one has to be the hypotenuse. So side B is the hypotenuse, and C and A are my legs. So if I want to plug this into the Pythagorean Theorem, I'm going to write it over here, and then I'll go down here. I'm going to have, oops, sorry about that. I'm going to have 10 radical 2 squared plus 10 radical 2 squared is equal to 20 squared. We have to see if this is a right triangle. So let's go all the way down to the bottom and see if this is actually going to work. I have 10 radical 2 squared, that's one of my legs, plus 10 radical 2 squared. Is that equal to 20 squared? Well, first let's take a look at 10 radical 2 squared. I'm going to do it on the side here, because you might not remember. But 10 radical 2, it's the same thing as saying 10 times radical 2. And if we're squaring a product, we square all the terms of the product. So this is the same thing as saying 10 squared plus radical 2 squared. So 10 squared is 100. I'm sorry, times, not plus. My bad. Please excuse me. 10 times radical 2 squared. Radical 2 squared, anything, the square root of anything squared is itself. So that would be 2. So that is equal to 200. Back up to my Pythagorean theorem here. This is 200. This is 200. It's the same thing. Is equal to 20 squared. Well, 20 squared is 400. Well, I have 200 plus 200. I have 400 is equal to 400. So I have now verified that this is in fact a right triangle. Back, let's give ourselves a little prize here. Right triangle. Yay. The last step of the problem is to calculate the area. So if you remember, the formula for area is 1/2 base times height. That works for any triangle. But since I have this right triangle, what I'm going to do is I'm going to kind of redraw it here in my mind. So I have my base of 10 radical 2 and my height of 10 radical 2, because they're the same. This is on isosceles right triangle. I've kind of turned it on its side there. There's my hypotenuse. I know it's 20, but all I'm really concerned about is my base and height. So if I have 1/2 times my base, which is 10 radical 2, times my height, which is 10 radical 2. Well, interestingly enough, I've just squared 10 radical 2. So 10 radical 2 squared, right? 10 radical 2 times 10 radical 2 means 10 radical 2 squared, and I already figured that out a minute ago. That turns out to be 200. And I have 1/2 times 200. My area should be 100. So I just paused the video here, went over and looked at the solution manual, and yes, in fact, the area is 100. So this problem is correct, and that should give you a pretty good sense of how to work all of these problems.